All right, calculus, welcome to your chapter 5 quiz number 2 review. All right, we're going to make this happen one way or the other in the future. Evaluate each indefinite integral or definite integral. All right, now, mostly going to show you the answers for this because hopefully by the time you watch this, first time or definitely second time, you'll know how to do this well. Number 1, we just simply take the antiderivative, 1 power up divided by the new power, plus c. No use substitution needed at all. Same thing with number 2, no use substitution needed. Just do it. Find the antiderivative, 1 power up divided by the new power, 1 power up divided by the new power, plus c. All right, next one, this is the same thing as putting a 2, well, the 2's on the outside, 1 over x dx. That is 2 natural log. Technically, it should be natural log in the absolute value of x plus c. Okay, but if you wrote it like I did, that'd be okay. On this next one, we want to rewrite everything with fractional exponents. Okay, as I did there, 1 power up divided by the new power, plus c. No bounds here. No use substitution needed at all. Number 5. Holy cow. So what I did is I rewrote it. That is 5 times x to the 1/2. This is x to the 2/3, negative 3 on the outside. 1 power up divided by the new power. That's easy for this one. 1 power up divided by the new power times 5. I just put the minus 3 on the outside. 1 power up divided by that new power plus c simplifies to be this. All right, no big deal. No use substitution needed on 5, nor on 6. Divide everything by power of 2, like 2x squared. All right. That is 3 over x minus 7x squared. That is 3 times 1 over x. Antiderivative of 1 over x is natural log x minus 1 power up divided by the new power plus c. And again, on 7. Divide everything by x to the 4th. That would be 1 over x minus 1. That is natural log of x minus x plus c as the antiderivative. No use substitution needed on the entire first page. All right. Number 8. Again, just distribute. We got 4x squared minus 4 times... should not be 4. Should not be 4. Uh-oh. And I don't have a pin down here. So, I don't believe I have a pin down here. Oh, no. So, hopefully you're listening here. That would be wrong right here. We might have to just pause the video here. It's going to be 1 power up divided by the new power. Most stories, the 4 is not going to be on the outside. It's just going to be 2. So it's going to be this, and then this plus c. Got it? The answer I have down here is wrong. There is no 4 there. So hopefully you're listening to this. There is no 4. 1 power up divided by the new power. This is going to be your answer. 4x to the 3rd minus 2/7 x to the 7 over 2. And then plus c. Right? Yes, that is clearly minus x to the 5 over 2. There's no 4 there. All right. Anyway, hopefully we don't do that again. Here is where you now need to use substitution. All right. If you let u be sine x, then du would be cosine x. And that'll be du. Right here, cosine x dx, and that'll be u. So I want to have u du, 1 power up divided by the new power plus c. What is u? Sine x. So it's sine squared x over 2 plus c. And 10, you just do it. The antiderivative of negative sine is regular cosine, positive cosine x. 4x plus cosine x plus c. You've done this one before in your notes. Tangent, you're going to write a sine over cosine. Now again, I'll let you write the answer as this. I didn't make you call it, because technically that could be a negative to the negative first. Cosine x to the negative first is 1 over cosine, which is natural log of secant plus c. That is the true answer there, but I'll let you leave it like that. All right, u is cosine x. If u is cosine x, then du is negative sine x dx, so take care of that. Put the negative on the outside, you'd have 1 over u du. Antiderivative of 1 over u, natural log, absolute value u. All right. Cotangent. Well, what is cotangent? Cotangent is cosine over sine. So, again, going to let u be sine x. So I'd have 1 over u, something over u. Du is cosine x dx. So that would be du. So it would be 1 over sine u. Or 1 over u, I'm sorry. Natural log u plus c. So there you go. The antiderivative cotangent is natural log sine x plus c. Interesting. Antiderivative cotangents is that. Huh. Cool. All right. You don't really need to use substitution here because you can, if you do use substitution, there's what we got, but you know then, sorry, I'm getting updates here on the UK imposing a national lockdown, which was probably needed 2 weeks ago. So the antiderivative of e to the u would be e to the u instead of multiplying. This is an easy derivative. The derivative would be 4. So my antiderivative, I would divide by 4 or multiply by 4. All right? Then, so that's the antiderivative. I don't really need to use substitution here. I plug 1 in for x, which is that first part, minus, I plug negative 1 in for x, which is that second part, and that is an acceptable answer. First one with bounds, number 13. All right. 14 requires no use substitution. What's the antiderivative of sine x? It is negative cosine x. Plug in pi, plug in 0. There you go. It is 8. All right. This is simply 3 times 1 over x dx with bounds of 1 and 2e to the 5th. Antiderivative of 1 over x is natural log x, but there's a 3 on the outside, so 3 ln x. Upper bound e to the 5th, lower bound 1. Plug in e to the 5th, plug in 1. Natural log of 1 always 0. This is something you learn in Algebra 2. Natural log of e to the 5th would be 5. 5 times 3 gives you 15. All right. Next one here, just do it. 1 power up divided by the new power. Plug in 3. All right. Plug in negative 3, so minus. Remember, it's capital F of B minus capital F of A, with B being the upper bound, A being the lower bound, capital F meaning the antiderivative. Simplify it how you want. That is what we get, I believe. We've done one like 17 before. All right, here it is. Now, I didn't change the bounds to reflect u like I would do in our notes. So I made these answers before. I probably would have just changed the bounds and made the bounds in terms of u. But if I would have done that, then I would have had I would have to make my lower bound then my upper bound. Anyway, I'll show you an example as to why that could be problematic on this one. Anyway, if u is 3 minus 5x, du would be a negative 5 dx. I want my du, though, to simply be dx. So that's the x is missing here. It should be dx. Negative 1/5 du is what dx is. There's a lot missing here on 17. In fact, we're gonna have to pause this video and start again with 17. Do not write 17 down. I'm gonna get a pen. This is Yak Math Videos signing out for a sec.